Welcome back, everybody. Today, we're finally diving into the exciting world of cloud deployment. We will go through the whole process of deploying a Node.js API that we've created 2 weeks ago to AWS. So, if you are looking to take your app from local development to a live production environment, you are in the right place. But before we start, let's take a deeper look at what are we going to cover exactly. As I already mentioned, we'll be deploying our Node.js API to AWS and, to be more specific, AWS ECS Fargate. Today, we will cover technologies such as, of course, our tech stack, with Node.js and Express.js, our API that we've built, and I'll show you again a little bit about it. We'll be using Docker to Dockerize our application. We'll be using ECR, which stands for Elastic Container Registry, and I will go over a bit more what are these things exactly when we're actually starting to work with them. Then we'll be using ECS Fargate, as mentioned before. We'll use AWS Secrets Manager, as well as AWS Certificates Manager, of course, Route 53, and lastly, we'll be showing you how to use AWS IAM so that we could use CLI in our machine. So let's go over what will you learn today together with me. First of all, I will show you how to set up your IAM with AWS CLI so that we could control and interact with AWS from our CLI. Then I'll show you how to containerize your application for consistent and portable deployment. We'll see how to work with ECR, basically how to store and manage our Docker images inside AWS. We also see how to work with ECS Fargate, basically to run our containers serverlessly without managing any servers. We'll show you how to use application load balancer in order to distribute the incoming traffic accordingly. Then we'll use auto scaling to see how can we automatically adjust resources based on the demand to save on cost. Also, as mentioned, we'll be using Secrets Manager for storing and accessing secrets securely, something like database URL or passwords. Then we'll be using AWS Certificate Managers to get our SSL certificate for HTTPS. We'll also see how to create basically a virtual private cloud. This is going to be an optional step for a lot of people, but I will still showcase it in case you want to take it a step further. And lastly, we'll see how to work with Route 53, how to manage your DNS and custom domains. So you might be wondering, who am I? I'm Lucas. I am a former university instructor in software engineering. I have a startup for more than 6 years. I am a CTO and co-owner of it. And I'm also in the field of software engineering for a very long time already. So as it states here, I was developer first, and now I'm trying to educate as much as I can. But yeah, as you know, everybody is learning every day. So yeah, you can teach me something new as well, guys. So I think it's time to get started. Okay, maybe I tricked you a little bit. I still have a few things to mention. First of all, I want to really quick talk about React Native Mastery. Some of you might know that this channel is very heavily based on teaching you how to work with React Native, and our Vadim really worked tirelessly on creating React Native Mastery. It has basically everything that you want to know about creating basically production-ready React Native applications. So if you really want to check it out, go to the website or just type in Google React Native Mastery and you'll find our website where you can check out what we are offering there. Lastly, I want to showcase you this magic link where I'll be using, let me show you, this guide. Basically, I'll be using this guide throughout the whole tutorial myself, and maybe I'll switch to this. Yeah, I'll be using this guide throughout the whole tutorial because it has little lessons where if you open one of them, you can see a lot of different information about what are we actually doing right now. And maybe I will forget to mention something, or maybe, for example, for things like creating task definitions, there are so many different fields that you need to go over, and then basically I just couldn't do that in one sitting. So I have this whole task created for only creating task definition. You can read about each field in the form that you'll see a little bit later, and yeah, you can understand maybe a little bit better why are we needing this, what this field exactly does, and what kind of settings you can choose from, and also my recommendations of what you should pick. And of course, I'll be going through the most important settings, but there will be some optional, very optional, I would say, settings that I will leave out. But yeah, so to get this, you can go into the description of this video and you will see a link similar to this, basically saying download asset bundle and step-by-step guide. And if you click on this link, you'll need to leave your name and an email address, and we will send you this document to your email address. So basically open your email address, click download now, and you'll get here. Okay, I think we are good. Let's see what the chat is saying. Hello from Gabon. Hello, hello. I see 2 people are from Gabon. Nice to meet you guys. Hello, sir. How are you? I am good. How are you guys? I hope you're doing well. I hope you're having an amazing day. Gabi, exciting, eager to learn. Yes, yes. Thank you. Thank you very much. Hopefully you're gonna learn something new. Vadim, may you do a video about Firebase Studio, beautiful React Native project. I will. Okay, so actually our team members are already replied to you, but yeah, maybe Vadim will do that. So without wasting too much of your time, we can get into our first lesson, which is called preparing project. So we can open it in a big screen and see what we need to do. So first of all, we will go over a little setup of what your application, your API needs to have, and then we'll get into the whole AWS thing. So first of all, as you can see, we need to add a health route for your load balancer checks. And I will explain a little bit more later what are these load balancer checks and what they do. Actually, you can read already here why are we implementing this, but I'll talk about load balancers themselves a bit later. But basically, to put it in very short, we are creating this link so our load balancer could call it, and if we return 200 OK response, it thinks, okay, this basically API or application is good to go and it's healthy. So how to do that? Well, actually, it's very easy. You just copy this little part down here. You can go to your project that if you worked with me creating it 2 weeks ago, you can follow exactly the same. Or if you have your own application, just go to the index entry file and add this route, basically /health, and send a request status. Okay, after doing that, we can right away very easily test it like this. So what we need to do, first of all, run our API. So we would say npm run dev. We can see that it's already running, and we can send a request. We can see that it returns okay. That means everything is working, and we can stop the server. Well, the first lesson is done. So we can go right away into the second one, which is going to be setting up Docker. It's going to be a little bit longer than the previous ones, but yeah, I'm gonna show you as best as I can. So first of all, what is a Docker file? Well, a Docker file, as I say here, it's like a recipe for your application's environment. It's basically a script that tells Docker how to build your image. And we'll talk about images a bit later and what are they, but I think you'll understand even by yourself throughout the process. But basically, we automate this setup and ensure that our app runs consistently everywhere. So it's a little file that's not going to take us too much to go over, but basically you can follow this line by line and copy everything inside your Docker file, or you can go here and find it right away, the full file. I will maybe go over like step by step to explain a bit more what are we doing there. So the first thing that we need to do is actually create this Docker file, and we will do it in our root of the project. So in here, click this and say Docker file. Now that we created this Docker file, we can start adding the code. Well, first of all, we need to define our base image. And basically, this is kind of the starting point of the image. And you can have it either with Alpine or just the full node version. It's packed with the full node version packed with a lot of tools, but as I say, it's very big in size. And Alpine versions are smaller based on Alpine Linux. It's a lot faster to download, first of all, uses less space, and it has a way smaller attack surface for better security because it's smaller in size. So it's, I think most of the time you will use this. There are sometimes rare compatibility issues that with native packages that might come up if you use Alpine, but they're usually very rare and quite easy to solve. So let's add this base image in our Docker file. And let's continue with what's further. So now we need to set our working directory. And what it does, basically, we're saying that /app is going to be our working directory for all the future commands that we will run. And this basically just keeps it organized without cluttering the container's root directory. So if we go here to our code, leave some space and add, oh, I didn't copy it. Let's copy this and add this as our working directory. Okay, let's see what's next. So now we need to set our environment. Basically, either you're creating this Docker file for production, and if you set it to production in this case, it will enable a few optimization things, and also it will ensure, for example, one of the bigger things is when you're doing npm install, which we will do a bit later, it will not install the development dependencies, which you actually don't need in your production build, right? So it makes your basically image smaller and better optimized. So let's copy this and now let's do it like this. Okay, let's see what's next. Well, as I talked already about, we need to install our dependencies and also copy the package.json and package lock JSON files into our directory, basically. And what this does, it isolates basically the Docker and lets the Docker skip the steps when you are, let's say, need to build this. So if they did not change, they will remain the same, and we will not need to reinstall them. So yeah, let's do that. Now what we need to do is we need to copy all of our rest of the files, basically everything that we have here in source and stuff, we need to copy inside this image. So we will do like this. And lastly, this is an optional step, but basically it signals it signals that we're listening on port 3001. This is, as I said, an optional step, but it's good to have it. So let's do this. And it's actually the same as we have here in process.port, which is 3001. Let's go back to our Docker file. And lastly, we need to specify a command to launch our app when the container starts. So this is actually like this. Yeah, this is actually what we have here in package.json. We could create here, let's say, prod, and then like have a different command for running production application. And then you would have here something like npm, then you would have run. And of course, inside here, you would have prod. Or if you're running development, you would have dev. But for us, the command is very simple. It's just run this like our source index, which is the entry file. Okay, we created this. We can save it and continue further. So now we need to create a Docker ignore file. And if you worked with Git, you kind of already can guess what it does. Basically, we're telling Docker which files or directories we should exclude from our image. And in here, I'm listing a few which are basically a no-brainer. For example, node modules, we are always rebuilding them with npm install here. So we do not need to add them. For example, for the environment files, this contains a lot of sensitive information for us, like our database URL and passwords. Then for Docker file and Docker ignore, we just don't need this in our, like these instructions in our final image. And lastly, Git and Git ignore, it's also something that is completely irrelevant to us. So it's just gonna take up some space. So let's copy this, go to our, again, root directory, and let's create Docker ignore. And let's simply paste these files. We can close it right away. And we are done actually with the whole application setup. Now we're gonna get into more things, but no longer any code. So what we need to do, first things first, we need to go to Docker Hub, which you can go through my link if you're following me inside the step-by-step guide, or you can simply go docker.com and you'll get here. What you need to do here is, first of all, you need to register and create an account, and then we will download the Docker desktop. So you will choose your own platform and download it. So I can just sign in. I think I'm gonna be signed in. Yes, I am already in. So you will see something like this, and you can go here, go to download and download your application. I think it might be that you will see here as well, the download button. But once you download it, we can confirm that everything is installed by running Docker version in our terminal. So let's open the terminal, and I actually already have it open, and run Docker version. I've installed the Docker prior to starting so that I wouldn't waste your time, but it's gonna be quite straightforward and shouldn't be anything too difficult. So if you see something like this, that means the installation worked. And now that we don't need this that much, let me change, the position. So now, after the installation is completed, we need to log into our Docker inside a CLI, and it's quite easy. You just run Docker login with a flag U, and then you pass your username. So it would be something like this, and of course it should be a real username. And I'm showing here how to see your username. For me, it's this one up here. So for you, it's gonna be the same. And I do this, and now it's gonna ask you for the password, and you need to provide your password. I don't remember my password by heart because I never write them with my hand, but I have it stored. So give me a second here, and I will do like this and save. If everything worked correctly, you might be asked and you need to allow it. You'll see login succeeded. So that's perfect. Everything is working so far quite well. Okay, and once we are in, I think it's time to finally build the image. So it's gonna be quite easy for now. Later on, we are gonna expand on a few things, but yes, for now, to build your image, it's actually simply running docker build /t and then giving a name and a tag for your image that you're trying to build. But to do that, of course, you need to go to your project. So my project is in documents, projects. Then I think it's called reminders or something like Apple. Let me check. It's called Apple Reminders API. Okay, Apple Reminders API. Okay, so now that we are in here, we can build our image. So what we would do, just copy this command, go back. Maybe I will make it a little bit bigger, and run docker build, and also give a name to my image. I will say for now, because it's an example, let's just give a name of my image. Now we'll see that Docker will build this image, and in order to confirm that the image is built, we can open Docker desktop that we've downloaded before. And where is it? Where is it? It's here. And we can go to dashboard. Yes. And if you go under images, we can see that we have created our image called my image, the same as we called it here. So now we can actually run this image and to test out if the application is actually working correctly. So to run it, this is the command you need to provide. And this is actually should be the name that you created, not the reminders API. And here you can see a little bit more explanation of what each line does. So basically, this simply maps to port 3001 on our host, basically to port 3001 in our container that we created, and which basically lets us access the local host. The environment file, you already seen this 2 weeks ago. It basically just loads the environment variables from our environment file. And lastly, we give a name of our image. So if we go back here and we run this, of course, giving correct name, my image, we should see something like this. And now if we open this local host, we don't have anything in the home, but if you do something like this, we can see that we have data return. That means everything is working. And today we are using, again, from 2 weeks ago, Neon database. So if we go here to tables and reminders, we can see all of the reminders that we have. And actually, we can see here that those reminders are exactly the same, like here by milk with ID 35. That means it's actually pulling them from database and everything is working well. So now we can stop this server and we will be continuing further to the next lesson. So let's go to our Notion guide. Let's go back to the board and check the next lesson, which is AWS CLI and IAM setup. Okay, let me take a quick drink. Perfect. So now we will learn how to set up our account so that we could safely, very important, we will be following the best basically recommendations for that, which is SSO, and how to do that so we could run the commands from AWS CLI and they would work. So first things first, what you need to do is you need to create an AWS account. So to do that, just click on the link or go to avs.amazon.com and click on create an AWS account. I will not go over every step that you need to do there because I think it's like 5 or something steps, and you will need to provide your right away credit card information. So it's going to take quite a while. We already have the account created, so I'm just going to use that. But for you, nothing will change. Just create an account, verify it, and you'll be able to use the same. So now we can go back, and actually we will no longer need this Docker home, so we can close it, and we'll no longer need the local host as well. So now what you'll need to do is we will need to follow the documentation of how to install the AWS CLI on our machine. So let's open this link, or you can try going to this link, but it's going to be quite difficult, or try Googling something like installing or updating to the latest version of the AWS CLI. And in here, select your operating system. For me, it's Mac OS, but for you, it might be something different. And then if you scroll a bit down, let's choose the command line installer because that's way easier. We just need to run 2 commands. And the first command is going to be this one. So let's copy it and go here. Do not run this command inside basically your Apple Reminders API directory because it will install it there. Just open, let's say, a new tab and make sure you go, or even like, if you are new in the terminals, what you can do is simply close. Of course, let's terminate this task. Close it fully. And then if you open, again, the terminal, it will open for you basically where you want to be. So I will increase it again. But if you know what to do, you just can navigate it with CD. So now, if we run this command, it will download this package basically. And now with the second command, we will install this package. And let's run it. Provide your computer password, and it will install in a second. Here you can read a little bit more about what these commands do, but I just gave you a short, like basically introduction of what it is. So we will need to wait a little bit, and in this tutorial there will be a few times where we need to actually wait, but we have time, right? And I see already people are asking how to access the Notion guide, and the Notion guide is inside the in the description of this video, or you can just go in. I have it somewhere here. Yeah, here is the link. Basically, assets.notjust.dev, deploy AWS ECS. You'll need to provide your name and your email, and we'll send the Notion guide to your email. That email will have a button saying download now, so press it and you'll access it. Okay, so now that I see upgrade was successful because I had already this installed, but you might see some different messages. Don't worry about it, just continue with basically the guide. And the next step we need to do is simply run which AWS to test out if everything is installed correctly. And if you see something like this, or on a different operating system, it might be different. So you can just try running this command lastly and seeing basically something like, in a second you'll see, if you see something like this, that means it was installed correctly. But if you see something like AWS command not known or wasn't found, that means the installation did not succeed, and you need to basically try to repeat it. But now that we have this installed, we can close it and continue further. So now the next thing that we will need to do is configure our AWS credentials. Basically, we need that so that we could interact with different services. And CLI needs that to know that you're authenticated and you can do that. We will be setting up short-term credentials because that's basically the most secure way, the best practice way. But you could, in theory, do it with short access. Long-term credentials. Yes, I think they're called that way. So to do that, what we need to do is, first things first, go to your AWS management console. So basically, after you create an account, I will sign into my account. You might see something like this. So what we need to do is we will need to go to IAM, Identity Center. So here, right now, let me go to the next screen and go there, because there is some sensitive information there that I cannot really show, but I will go back really quick. I'm here, and let me explain you. So in this dashboard on the right side here, you have some sensitive information. In theory, if someone would see all of that information, nothing really bad could happen right away, because they still need a way to be authenticated, basically to have a user. But it's kind of not a good thing to show them. So once we're here, we can create a new account, and what you might also need to enable this. So you will see it saying pop up or on here on the right saying enable the IAM Identity Center. But to do that, you need to be on an admin account, and you need to be with a verified email address. It's quite easy. Most likely you will have that. So once we're here, what we can do is we can click add a new user here, or if you already have some users, just click it here. Here we will need to provide a username. So I will say something like Lucas, or let's follow not just Lucas, something like our channel. Now I need to provide an email address, and this email address needs to be a real email address. So confirm this email address, and I'll just provide the first name and last name. In here, you can provide more information about the user, something like how to contact them, their job positions, address, and stuff like this. This is not mandatory. You can leave it out as well. This is more leaned towards bigger corporations for easier management. So let's go next. And here you'll find a group. We can create groups. For us, if you're only like a lone developer, you don't really need this group. So this is, again, more leaning towards big corporations. For example, you could have a developers group that would have power user access permission. So every user in the future that you add new developers, hire new developers, you just add them to that group and that's it. You don't need any extra setup, which simplifies things quite a lot, but we don't need, so we will click next. And here you can just review everything that you did. So now we will just click add user. And now you will see something like this once you created the user. In here, let's click on the user. And here you will see that the email address is not verified and we do need to verify it. So you can, if you created this like a long time ago, you can just click send email verification link. But if you just created it, you will have it automatically in your inbox. Check also the spam folder, although I really doubt it should be there. I'm doing the verification on a different screen because, yeah, it also shows some sensitive information, but it's pretty straightforward. Just click the button, and then once you are done, you will go here and you will see something like this after clicking confirm, where you will need to provide a new password for this user. So make sure that password is also secure. I'm doing it on a new screen. So now once, let me save this. Yeah, once you create a new password, you'll see something like this. And I stored my basically, yeah, credentials under this username. But actually that's not the username, because the username is not just Lucas, but this is gonna be the password. So if I sign in, I will see something like this. And you will need to verify basically your account when registering, and most times than not, and probably the easiest way, is going to be by using this authenticator app. So if you click on authenticator app and click next, you will see this screen. So here you need to install either Google Authenticator, Duo Mobile, anything that you use if you already have them. But you can, if you don't have them, you can install them from any store of your phone. And then once you do, click show QR code and scan it. Of course, I'm gonna do it also again off camera. So let me take my phone and scan this QR code. Actually, first of all, yeah, you go to the Authenticator app, click the plus, scan QR code. I'm gonna scan it. It just added a new code. So now that I can share this already. So now that you scanned it, you will see a new entry, and just write a code for that new entry and click assign multi-factor authentication and just click done. Once you are done, you will see you have, yeah, basically, if you go back to the manager's account and reload this, give me a second, you will see that it says verified. So we can just close this. So now that we have a verified user, we can continue further. And the next thing that we will need to do is assign some permissions to this user. So to do that, just go to AWS accounts, and in here, click assign accounts. So for now, I have only one account, and this is good enough for lone developers, but it's, let's say, not the best practice for large teams. In larger teams, you would have, let's say, at least 3 accounts. So this account would be the management account, and this account is going to be primarily responsible for managing billings and cost allocations, setting up the organizations, adding new IAM users, and you would not store anything on this account. Now you would create 2 more accounts, something like development or production, and those 2 accounts would have more permissions. So development account could have some experimental permissions, and we would isolate the development data to that account. And in order to create these different accounts, you can open here AWS organization. I will open it in a different screen. And in here, yeah, we already have like a development account, but I wanted to showcase this, but I thought like this is way too much of an overkill for starting out. You really don't need that when starting out. This is usually for big teams where the security is number 1. And yeah, so what you would do is click add an AWS account, and here give a name, something like, let's say, production account. And also here you would have the email address and create new accounts. And then in here you would assign that development account. But this is, as I said, a bit of an overkill and definitely not necessary. So what we could do is we could simply assign the management account in this case. So after selecting it, we would also need to create a permission set. So to create that, click this button, and in here, let's select predefined permission sets. You can create even a custom permission set, but that's all like also if you want to like very fine-grained security, but because we are actually the admins ourselves, we need a bit more power. So administrator access would give you all access to like all services, all resources. You can leave this, but you can also have something like power user, which gives access to all AWS services and resources, but just does not allow you to manage users and groups. So this is something that is good enough for us. So when you go here, you can provide optional description, select a different session duration, but in theory, all of the default values are good. So just click next, review all the data, and press create. Now that we have this permission set created, we can go back here and reload with this button, select the power user access, and simply click assign. It might take a few seconds to assign it, but once you are done, if you go to AWS accounts, you will see that there is an AWS account attached to you with a certain permission set. So now that we have this ready, we can continue, and let's see what's next in the guide. So yeah, here I talked a little bit about assigning permissions, and here you can find even more data about how these 3 accounts would work. But as I say, even here, like for developers, small teams, or early stage project, simple 1 account is completely fine and also cheaper. So yes, now that we go further, we will be needing to configure the AWS CLI with our SSO. So if we go back to the terminal, in here we will need to run this command, AWS configure SSO. So let's go here, let's run this command, enter, and I will need to provide some name. This can be any name you like, something you can even copy myself, something like my SSO, you can call it Lucas SSO, you can call it whatever you want. I will call it my SSO. Now for the start URL, what we need to do here, and this is one of the things I really didn't want to expose too much. Alone, it doesn't do anything bad, but that will be one step closer to being for some bad people to do something bad. So to get this start URL, what you would do is go to your dashboard, and here on the right side, you will see something like here. setting summary table, and then AWS access portal URL, and you will see some URL like this with the start at the end. Copy that, and I will do the same but off camera. And now I will need to somehow, let me go here, copy this. And now I will move this also to my other screen to paste it. Now I will need to hide it. Something like this. Okay, yeah. So the next thing that you will see is going to be the SSO region. And you can find the region as well in the same setting summary table, but it's going to be under region. And you need to copy only the second part, basically, in which region you are. So US East 1 is kind of common one, and most likely you might be using that as well. So just go here and write that or copy. So US East, and for us it's 1. Let me click the enter on the other screen. Okay, perfect. The next thing that you will see is going to be SSO registration scopes. And this is, you need to leave it on the default, SSO account access. This is 99% of the time exactly what you need, and this is, in our case, 100% what we need. So let's just click enter and nothing else. Now, after you have finished this step, you will see this screen appear on your browser. You might need to log in again to the user that we just created, that I called notjust Lucas, and you called it whatever you liked. So you will see this allow bootcore client MySSO to access your data. And this is very important to allow because this allows CLI to fetch and cache the credentials for our sessions. So click allow access and you will see request approved, blah, 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 blah. And in here, you will continue to the next step right away. So we can close this and set the default region for our CLI. Basically, this will be, if you do not use, if someone, like some commands need a region and you don't provide, this is the region that they will use. And most likely it's just gonna be the same as you had for your region previously when you were when we were setting up the SSO. So provide that region, click enter. For the CLI default output format, we will use JSON. And profile name, this is also, you can call it whatever you want, because you can call it Lucas, development, production. Usually development and production are good names for profiles, but I will call it development because that's exactly what we're doing and we will be pushing, or actually prod. But now that I created all the a few further commands with dev, I will leave it. But now that I'm thinking it, probably production would make more sense because we'll be releasing our API to production. So I'm just gonna call it dev. That does not matter at all. You can run this command to check if everything was set up correctly, and if it was, you will see a JSON return for you. But yeah, I will not do that because it also has some information, and it's not necessary because you can run this command. If we scroll down, this cat/avs config, and if it returns something with actually, let me run it off camera and then I will show you only the things that I can. So if I do something like this, let me adjust a little bit the view. Okay. Actually, this is the most I can do. So yeah, you will see something like this, like profile dev, SSO session, and then there's a lot more information. But if this command returns all of this, at least like this profile dev, that means the setup was correct and everything worked out as we wanted it to. So now that this is done, we can log in to our SSO, and to do that, it's simply running AWS SSO login, and then after this /dash, you will have the name that we needed to provide here. So as I talked, like dev, prod, whatever you chose. So now let me actually clear everything so that I could have it nicely here on the main screen. Okay. Later in the later steps, I will not be hiding that much everything, but yeah, for now I needed to do a little bit of hiding just not to compromise our account, AWS account. Of course, it's a development account. I will remove everything still afterwards, but at least throughout while I'm developing. So now, yes, it's time to run this command. So copy it, paste it, and you will, if your session ever expires, you will need to do this AWS SSO login profile and then provide your profile. Because we already logged in, we no longer need to do the same login. And you will, if you go, you will see this request approved, and then in here it will return basically that successfully logged into, and actually the start URL. So now that so now that we are logged in, we can continue further and check out how to finally use this AWS CLI and how can we push the images and things like that. So why is it always perfect. So let's go back and let's go. Just a quick mention again. Once you run this, you will need to provide your username, your password, and then also the authenticator code. So don't forget about that. The next lesson is going to be how can we push the image that we build inside Docker to the AWS, basically. So, okay, let me check some comments. Where can I find the part 1 for this video? Where is the video where you deploy the... we don't have a video where we deploy. This is where we're gonna be showing how to deploy in this video. I'm just showing you like everything if you're new, what you need to do to be able to have it deployed. So you will need to have the CLI set up with IAM. So that's why I'm showing that. 2 weeks ago, and you can find in this channel under live tab, we were building this full stack application with the Node.js backend API and then the front end with React Native. So if you go to this channel under live tab, it will be called something like your first full stack application, and you'll see how we built this Node.js app. So yes, now let's continue and let's go to another lesson, which is called pushing images to ECR. So actually, I can already bring back my AWS dashboard here. Yes, so now that we have everything is ready, we can see even that we have multi-factor authentication already attached to this account, and means everything is good. We can go to ECR, Elastic Container Registry. And once you're in here, what we will need to do is create a new repository, basically. So just click Create Repository, and in here, give a name to your repository. Basically, again, whatever you want. I will call it something like Reminders API, or maybe, something like Reminders API would be good. The image tag mutability, this is not like a very, let's say, crazy setting. If it's mutable, that means I'll show you how to do it. You can override the tags, and you can simply leave it all the time with the latest. If you select it immutable, then the tag needs to always be different. We will leave mutable, but because I'm trying to show like the best practices, we will not keep the latest tag. We will have some sort of versioning. So yeah, you can choose whatever you want. And for the encryption, most likely you will leave AES 256, which is the industry standard, as it says here. So once you have it already, click Create, and you will have your repository. So now what is this repository? Actually, here is it. This repository is something that we can keep our Docker images in, so that we could use anywhere in this Amazon AWS basically infrastructure. It allows us to like version, store, manage, deploy, and do everything that you imagine with Docker container images, and it's secure. We don't need any extra external registry infrastructure. Everything is here and ready. And it's also very let's say, relatively easy to set up with GitHub Actions or GitLab CI, basically CD, and yeah, it will push them automatically here. Maybe I will show this sometime in the future if there's any interest how to do that automatically. But now that we created this image, you can click here, view push commands. And here you will see some basic commands on how to push your images. But for us, almost all of these will be different because, first of all, this one is going to be different because how we authenticate. And this is because it's with latest, and that's actually not the best practice. And yeah, so you can try to copy it or just follow me. I would suggest following. So now that we have this terminal, let's go back to our project. And actually it's in documents, then projects, and then Apple reminders API. So we're back in the directory where our basically Node.js API was created. So now in here, one command that we need to run, and if you go again inside the Notion guide, you will see all of the commands with deep explanations of what are they doing. So this command is actually quite a simple one. Well, it looks very let's say, yeah, difficult to understand, but it simply retrieves a temporary token from AWS with this profile that we provide. And it also uses it to log into Docker using this token and these credentials. So let's just copy it, go back to our code, run this command, and click enter. After doing that, yeah, you might see this, click allow, and we see login succeeded. That means everything so far is working well. And again, this token will expire, so in the future you might need to rerun the command. So keep that in mind. Now that we have logged in successfully, we can finally build our Docker and as you can image. And as you can see, this is a little bit different than what we've seen before with simply build and then the name. We need to provide these, for example, this provenance false to disable the extra metadata that it adds. If you don't have this and you push your build to ECR, it will have 3 different images pushed. And we don't need that. We need only one without any metadata. So this is what we will keep. Now for the platform, you might not need this. Because my MacBook, my actually Mac computer that I'm using uses Apple M chips, ARM64, I need to provide this flag and specify on which platform I need to build it. Because this basically platform is the most common one, the most used one. That's why I'm gonna build it for Linux. And then with a T, we will provide the name. And after the name, we'll provide the tag that I was talking about. So you could have here latest. It's not the best practice, but releasing updates might be a bit easier. But rolling back is going to be difficult. So we'll follow the best practices and provide a versioning. So if you paste this command here, maybe I should make it bigger. Yeah, something like this. So once you have this command, I will rename it or just keep it. Let's keep it reminders API. And this version tag, you can have any versioning you want. You can have just like this. You can have with V. I will keep it with V. And then also the dot is important because that's where we're saying where our Docker file that we created is. And we're saying basically it's in the root directory. So just find it there. After you click enter, it will take some time to build this image. But once it's done, you can go to these images and you can see here that we created reminders API with the name exactly as we provided. And you can see this warning, and it's only for me because I'm using, as I said, Apple M chips. You might not see it if you are using Intel chips or Windows computers. Actually, I don't know how it's going to be on Windows, but yeah. So now that we have our image built, we can continue further. And what we need to do now is we need to tag this image for our ECR container. And what this does is this basically links the remote image that we just built. The local image that we just built, which is called like Reminders API with the version 1.00, to remote ECR repository that we created here. And it will look something like this. So let's copy that and go to the terminal and paste it. So as I said, we're tagging this image with this repository, and here also we're providing the name for the repository and also with the version of 1.0.0. Let's click enter. If you go here, you will see once again a new image created with the name of, longer name and a tag of version 1.0.0. Now, the last step that we need to do is we need to push this image to the ECR repository. And this is actually very easy. Just copy this command or stop the video and write it down and just push this exactly, or this if it's easier for you, to the repository that we created. We might need to wait 1 second, but it shouldn't take too long. Now that we've pushed everything is worked, no errors, we can go back to the ECR, reload it, and we will see our image pushed. We see the date, which is exactly now, and with the image tag of version 1.0.0, and that means everything worked perfectly. So now we can actually close this. So now that we have our image, we can continue going deeper into the dark waters. So let's open another lesson, which is called ECS clusters. Actually, that's still not the hardest part, but these two parts will be probably the most confusing ones. So if we open it up, first of all, we can talk about what is ECS cluster in general. And as you can see here, what I'm saying is like a foundation for your containerized applications. You put everything inside it. It organizes and manages different pieces that you need basically to run the app. And this is the best example like that I could think of. But it's like a neighborhood where all your applications and components live and work together. It doesn't run anything by itself. It just like basically some rules and provides a space for running the containers that we will push to it. So that's the best how I could explain. Just imagine it as a box where you put everything inside, what we will do later on. So to create this cluster, we can simply go to ECS, which is called Elastic Container Service. And in here, go to clusters on the left side. In this part, in this part, what we will do now is just create a new cluster. So here you'll see a few settings. I will try to go over them and explain a little bit at least of what are they. But if you need more explanations, go here and you will find more of them. So now let's give our cluster a name, and I will simply call it something like Reminders API cluster. It should be a clear name so that later when you see it, you understand, okay, this is for this application or something like that. These Service Connect defaults, we will not need them. They are optional, and let's skip them. You will not need them. Now for the infrastructure. And here where a debate comes in, what is better? Like to use a Fargate, which is serverless, to use Amazon EC2, or maybe to use EKS with Kubernetes. So which one is the best? And in here, I have a little bit written about them, but I will try to use that and also my explanations. So AWS Fargate, the thing that we will use today, is a serverless option. And basically, AWS manages everything for yourself. The whole underlying infrastructure, they do it for you. It's very great because it's simple. It scales automatically. It has almost none maintenance. Well, yeah, literally almost none. It's a little, in theory, let me add this. In theory, it's a little bit more expensive per resource than EC2's instance, but it eliminates the need of any management. So you don't need to do any patching, any scaling, any updates. AWS team handles all of that for you. So you can just focus on building the app. You will never need to go and fix, update, patch, or do whatever with Fargate. It's very, very good. So now I will talk about EC2 instances. And I have quite a bit of experience with this because our startup uses this. So yes, the EC2 instance provides you more control. And in theory, again, very important word, in theory, it can be a little cheaper. But to make it cheaper, you need to fine tune and optimize it very well. You actually need to know what you're doing to utilize the cheapness, let's say. Because if you provide more resources, it's just gonna run on all of that. And maybe you're using only 30% of what you're capable of. But you're gonna be paying for the whole 100%. And that way, AWS Fargate will be 100% cheaper. So that's what I'm saying. You need to have a person that understands what he's doing to have it actually cheaper. And also with EC2 instances, you need to manually plan the whole patching, scaling, updating, everything you do yourself. So basically, you're wasting your time that you could be building your application, and you're just managing this. And I can't tell you how many times it took me a very long time to actually update or patch something like with EC2 instances where I was thinking, wow, I'm wasting so much time. No one will see what I'm doing. It's just wasting time where I could be building my app and improving it even more. So it's your choice, but this is what I would go for. Of course, if you are insane, you know how to use Kubernetes, you are working in a huge team, like very, very big team, maybe even, as I say here, EKS might be better for you, but it's very expensive. As I say here, like plain cost will be 74 a month per cluster, and also you pay for resource costs on top of that. And you usually, if you're using this, you will have a team that handles this kind of things for you in the organization. They have dedicated teams just for that. So it's quite difficult to understand, maintain, and implement correctly. But it's very powerful and very flexible. So now that I rambled a bit, hopefully I've helped you make up your decision. And if I had to choose again, I would definitely go with AWS Fargate. At least for now. Maybe later you can change it if you want, but I would keep it definitely. So now we have a few more options. One of them is monitoring. And for monitoring, when you're just starting out and when the application is smaller, I would suggest keeping it off because others cost money. This one you would probably need it for very complex applications with a huge traffic, and yeah, it costs the most. This one is kind of a good middle ground, which gives you enough data and it's not that expensive, but will have enough monitoring without paying anything extra. So I wouldn't even touch it at all. And the rest, like, just keep it on default. They're good enough settings. Tags just help you identify and organize these clusters, which is good, but definitely not needed. Very, very optional. So now that we have all these settings, let's click create. And it will take a few seconds to create this cluster, but we will not waste our time waiting for it because we can right away get into the next lesson, which is where, as I said, the actual deep waters are in. ECS task definitions. So before starting, let's check out real quick some comments. Hi from Cameroon. Hello. You have contributed so much in helping building my career. Thank you so much, deeply, the bottom of my heart. I can't tell you how much these words mean to us. I'm very, very happy for you. I hope you'll reach the highest of the highs that you want to reach with your career. And thank you very much for watching, for contributing. And yeah, thank you. How's the hackathon going, y'all? Okay, that's very interesting. That's good. Are you actually mobbing participating yourself? I saw some very interesting things happening, at least on Twitter. So we'll see. I can't wait for the deadline. By the way, will the Notion guide be accessible? Yes, it is. It should be actually even now accessible. I'm not sure. Maybe my team can. I see even the comment. You can go to the description down below of this video, and you'll see get step-by-step asset bundle guide. You can click there. You'll get to a screen where you need to provide your email, a name, and we'll send you the Notion guide. Or you can just go to this link right away. Assets, notjust.dev, deploy AWS ECS. And you'll get the Notion guide for you, and you can read it at your own pace, everything. So let's take a sip of water. It's very important to stay hydrated. Okay, let's continue with task definitions. So yeah, even here, I say like, we'll go over all most important settings because let me show you, and actually it created in the meantime the cluster. But let's go here to task definitions and let's click create new task definition. I will just show you how many different settings are here. And here you can expand all of these here. So going over all of them would not make much sense because most of them, not most of them, but a lot of them are not even necessary for us. We don't care them, and they're very optional. So I will be going over the most important settings, which we will actually need. But if you want to see what other fields do, you can go to skipped fields and simply read about them. Why are they needed? Why are we not using them? Or you can stop right now and read it a little bit more. But we'll go over the important settings here. So let's go back to our create task definition screen. And let's start creating our task definition finally. So first of all, we will give it a name. A name should be, once again, something very clear so that you could understand it yourself. I'll give it reminders, API, task definition. Some people don't write these like task definition and just write TF. I like it to be very, very clear. So I will do like this. So yeah, this is the name. The next thing is the launch type. We already chose AWS Fargate, and this is actually what we are going to select here as well. So let's just select it and go next. This is the operating system architecture selection. It basically ensures the compatibility with our container image. And if you remember, we've pushed the image with AMD 64 format, which is this, Linux x86 64. So leave it and let's continue. This is going to be, if you're on a Fargate, the only option, and this is what we need. So now let's go over into task sizes. We need to select the CPU and memory total for all of our containers that I will talk in a bit that we are assigning. So this is like this selection of one vCPU and 3 GB of memory is it's a good selection for moderately busy APIs. If you're testing out, just go with 2 GB, or yeah, if you have a huge traffic constantly, you can go more. This is what we can adjust later in the future very easily, and we'll be able to make our decisions based on the based on the monitoring, the logs that we find. So you can probably start with, if you're releasing to production, with 1 vCPU and 3 GB of memory. Now, if you scroll down, we need to select our task role, and this basically grants containers the permission to call AWS APIs. And we will need this, for example, when trying to get our environment variables. So if you have already one created, just select that one. But if you don't, just leave this create new role, because we will need this. Okay, now that we have this, we can continue further. We do not need task placements, fault injections. I've written about them in the Notion guide. You can go over and read if you want. Now this is the very important part. So for the name, again, as always, let's try to give it very understandable name. So something like reminders, API, container. Now for the image URI. To get this image URI, you will go to ECR and open it in a new window. We already created our ECR, and copy the image URI, the image that we pushed from our CLI, basically. So now go back to a task definition and paste this image tag right here. We will leave the essential container as yes, because this is marks it as a critical container. Basically, if it fails, the task stops, and it is critical container for us. So let's go down. Private registry we do not need. I've written down here what I need to talk about, because I will definitely forget some of the important ones. Now port mappings. Port mapping is very important, and it is because we need to allow certain ports to be accessible. It basically defines how external traffic reaches our API. So as you remember, we exposed, and most times than not, you will use this port there. So we exposed the port 3001. So if we go here, simply select container port 3001, protocol is going to be TCP, and the app protocol is going to be HTTP. Because the containers itself talk with HTTP internally. We don't need to have it HTTPS. We will implement that later on, but this is for the internal communication. So yes, once you do that, you can just leave it and continue further. Now for the resource allocation limits. This is going to be resources that you allocate for one container. So for this, for example, image, for this Docker container image. And you can select CPU limit, and usually, because this is the only container we'll be running, we will select a full one. So let's just write one. If you provided more, you can provide more here as well, if in the infrastructure requirements. We provided only one CPU, and for now that's going to be good enough. Now there is memory hard limit and memory soft limit. The hard limit is basically the cap maximum memory the container can use. If it's exceeding that memory, if something like very unusual traffic is bombarding your API, you would terminate it, and so that the costs wouldn't overflow. So the hard limit is going to be 3, because that's the only container we're using, so we're also giving the maximum that we provided. And a soft limit is usually more for if you're using multiple containers, but this is basically, we're saying guarantee for this container at least this amount of memory. If it exceeds this memory, it's okay. It can go up to 3 gigabytes, but it always needs to have guaranteed of 2 gigabytes. So yeah, it's kind of allowing flexibility. So let's do it like this. Now for the environment variables. In here, well, they're important because that's where we define our database URLs, other API keys, port numbers. And the thing is that there are some environment variables that we can expose without like much protection. So for example, something like port number that we have in our env. The port number is something we don't really care about exposing, so we can have it like port value 3001. Now, for sensitive data, such as the database URL, for me, this URL I don't care because it's gonna be removed in a second. But you should always hide this URL in your production environments. Now, to do that safely, I couldn't just say here database URL and then say the value here, because it exposes it, it's not secure. So what we do to make it secure, we go to Secrets Manager, which actually is already selected for me. Once I go here into the secrets manager, press on a store a new secret button. In here, let's select other type of secret. Now the key will be the same as in our environment file of the API. And the link will be as the value. So now that we stored this, encryption key, just leave it as default secret AWS Secrets Manager. But now that we stored all of that, let's click Next. In here, we need to provide a name for our secret. So I would say something like production, reminders API, and here you can also like just follow this one, but we will see production reminders API. If you want, you can provide description, some tags. These are not necessary at all. So let's click Next. And in here, you can configure the rotation. For us, it wouldn't work because I cannot implement rotation with Neon to give me new URL every time. It's more leaning towards if you're using, let's say, AWS RDS or something inside their infrastructure to have even more security on top of that. So it's also even then not necessary and nothing crazy if you don't have it. So now just review everything here and click Store. After we create it, let's refresh and we see our secret. So now in here, what we need to do is copy this secret IRN, copy it, go back to tag definition, and inside here, say database URL value from, not a simple value, and we'll say value from this IRN, but we still need to provide to say which exact, let's retrieve secret values, which exact value they need to use. So let's copy this one, go back here, add double dots, paste the name, and actually I have a space here, that's bad. Paste the name of the key that it should stand for and add 2 more double dot at the end. Now we have configured it safely and according to best practices. So we can continue further. Now for the, you can add them all in the environment file, but again, you can do them one by one. So now logging. This is important and we will enable log collection because it will centralize all of the logs for debugging and monitoring right later on. So just enable it, select Amazon Cloud Watch and leave all of these on default. This is exactly what we want. Now, all of these, we do not need them in here for us. I've commented them in the Notion guide, all of them. You can read about them if you want. Why are they and why we do not need them? Just trust me now. Unless you have very specific needs, you might need them, but it's incredibly rare. So for example, this one, private registry authentication, only required if you're pulling images from non-ECR registry. We're using the ECR, we do not need that. Read-only root files, this is, again, we do not need that because we need to write temporary files like logs and caches. All of these very rarely needed for standard API workloads, and you should configure only if specific requirements exist. And so you understand the gist. Now for the storage. This storage is important. It actually already provides you by default with 21 GB. This is actually what we want. And this provides a storage for our API to cache or log or store some data. So provide 21, that's going to be good for most. If you have very heavy workloads, you can select 50, but 21 is more than enough. Now for monitoring, again, you can enable them. It's good. It provides some metrics for like traceability and performance to debug like your monitor API health and stuff like that. But we'll have enough logs from this, and when we're just starting out, we don't want to waste our money. Maybe we don't have, we want to save as much as possible, but still keeping it production ready. So that's why I think it's not that important at first to add. When you expand, when you create like big application, then maybe you want to expand it. But for now, no. And then for tags, again, we are seeing it everywhere. This is optional. It's helpful when you're organizing your resources by projects or environments or teams, but it's very optional. So once you went through all of that, we can click create, and it will take a few seconds to create. Actually, maybe I will make it a bit bigger. Not sure if that, no one commented that it's too small. Hopefully it wasn't too small. Okay, so now we have our task definition created. So what we can go back to our guide and see what's next left to do. Now, if we go to, basically let me maybe first introduce the problem. Now our execution role that we created and I talked about cannot read our secret database URL and it will fail. So we need to add permissions for this task execution role so that it could read or even write the secrets that we stored, and in our case the database URL. So if we go here and if we go to IAM, and let me first of all maybe do it off camera to see if actually there is nothing I could expose. No, not that much. So, okay. So if you go to this IAM, just click here, you will see this page, but you will be in the dashboard. Select the roles and try to look for this role that we just created. Basically, that actually our task definition created automatically. Once you see this role, click on it. And now we need to attach a new permission to it. So click add permissions, attach policies, and we need to attach this permission. So we can go back here, search for this permission, select it, and click add permissions. You can make it even more secure by allowing to access only, for example, database URL permission. But in our case, we need to allow it to access all of them. So let's leave it by default. So once you do that, that's it. Just close it and you are good to go. Now we can go back to our tasks and see the ECS cluster service. Open this task, and in here, we will need to create our first clusters. So now I'm again gonna do the same, go over the most important settings, which is almost all of them. There's a very small field of some options that I'm gonna skip because they're just not necessary for us. So, okay, now let's go back to our project and go to the clusters. Inside the cluster that we created, select it. And in here, we will create a service for this cluster. So basically, this is going to be the task that's basically running already. Click create. And in here, it already selected the Reminders API cluster by default because that's where I clicked on to create. But if you're creating it from like an external part, you will need to provide it. Okay, so now let's go over the compute configurations. First of all, there is two different configurations. One is capacity provider strategy, and the other one is launch type. For us, this is basically defines the underlying infrastructure for the tasks that we are going to run. For us, it's going to be the launch type, and the launch type is going to be Fargate. That's what we chose. The platform is very important to choose to run the latest. Maybe you, if like, I don't see a point if you're creating it from scratch why you would choose especially the older one. So I would just leave latest and continue. Now for deployment configurations, here we will need to define a few things. First of all, we need to select a task definition and that we just created. And this is the name that we call Reminders API task definition. We need to select the version of the task definition because later I'll show you why are we selecting here a version when we're gonna update our API. So let's select the first one. and I'll provide this service name. Once again, I'm gonna keep to the same reminders API service, and I'm keeping the same name and structure to always understand that I'm talking about reminders API. In the service type, just leave replica. This is basically defines how tasks are deployed and managed, and you cannot choose anything else here. So this is what we want. Now for the desired tasks. Here we can select the number of running tasks, basically the instances of our API. So let's select, you would select from 2 to 4 for high availability. This you can also expand later on, and I will also show you and talk a bit why we would and when we would want to do that. But for now, like, the good starting point is going to be 2, and we'll also implement auto scaling to automatically, based on the traffic that you are seeing, to make, like, add more tasks or make less of them. So yeah, but for now, let's specify 2. For the availability zone, this basically will try to distribute our ECS tasks evenly across different availability zones. So just keep it open. For the health check grace period, this would simply prevent the premature health failures. If, let's say, your task is starting up but takes a bit longer, if you leave 0 seconds, it will right away call for the health checks, but it will fail because the task is still not running. So leave something like 60 seconds, and the good practice is to leave from 30 seconds to 120 if your startup is a bit slower. So I would leave 60 to be somewhere in between. These 2 we don't need. I talked here a bit why we don't need them and where is it. Yeah, because the default settings are good. ECS automatically handles deployment failures and recovers without custom settings. Rarely needed for API service. So we can continue. Now, networking. This is a very big one, and I'm even thinking to leave it for the last. Yes, probably let's leave it as the last thing, because here we might need to talk a bit more about them. Or should we go over them now? Well, we'll still go over them because, yeah, we'll need to come back, just not to break something. So now, in theory, first of all, what is this VPC that we're selecting? And to put it in short, this is an isolated network where our tasks that we're defining will run. We'll have like routing, internet access, and security defined there. So what my recommendations would be to run the default VPC if you're just starting out, if you want simplicity, if you don't have a lot of users yet, and yeah, like you can keep it default. It's not let's say a best practice, but you shouldn't always chase those best, let's say, quote unquote practices. You need to see what you actually need and select it accordingly, because as for the best practice, it is recommended to create your own custom VPC, and but this will cost money, and it will cost quite a bit of money, because like only running NAT gateways that we will need to attach will cost you around $32 per month if you're running only in one public subnet, which we would probably do. That would be more than enough for now, but that still adds a lot of money, and that's why I would just keep it default. And if you are keeping it default, nothing really changed for the rest of you guys. But if you want to follow the best practices, and if you are not afraid to pay more money for that, we can do this. What it adds, basically, it adds a lot more security on top of our infrastructure. So I will show you how to create these VPCs easily. Click the Create VPC button here. You will see this screen. Click on Create VPC and More. This will basically have a VPC creation wizard where everything is way easier defined, and we will not need to do that much setting up. So if you do not have like too much of a knowledge, that's more than good enough. The naming we will also auto-generate. You could name them all separately, but there's no point in that. So I will call it something like reminders API VPC. And actually it adds VPC, so we can just call it reminders API. Okay, for the IPv4 CIDR block, we will leave it on default. That's good. For the IPv6 ER block, we don't need it, so we will choose no. That's for most of the Fargate plus ILB setups totally sufficient, and we can always add it later if we need it. For the tenancy, we will leave it as default. Now the settings. We will keep 2 availability zones, and that's also more than enough. For the number of public subnets, we will also have 2, the same as for the private subnets too. This is going to be more than enough for us, definitely. Now for the NAT gateways. This is the thing I was talking about. It even shows here. It costs some money. So if we're creating this VPC, we need it because without the NAT gateway, we would have no internet access to for private subnets. So tasks will not be able to pull ECR images or log CloudWatch. So this is bad. We need at least one in at least one availability zone. And that's going to be sufficient for most production APIs. It's cost efficient. But yeah, like if we have a failure in that single availability zone, so that could disrupt some that could arise some problems. But it's insanely rare and probably will not happen. I'm saying probably, but yeah, even that it will later go back on. You could have one per availability zone, but that is very expensive. That would cost you around $64 a month because we have 2. We would have 2 availability. Yeah, we would have 2 NAT gateways, 1 per availability zone because that's where we selected 2. We do not need that. So 1 is more than enough. Now for the VPC endpoints, we will keep it as S3 gateway. And for DNS options, we should keep both of them checked. Once you have all of that created, just click Create VPC. And now it will take some time to create it. So while it's creating, we actually can check the comments maybe because it will take some time. Rogelio, hello, let's go, Lucas. Nice to see you again here. Every stream, still here. Happy to see. Amazing. How are you doing? Okay, so it will take some time. Again, I will double down on that. Like if you are just starting out, your app is not crazy big, you don't need really this because it will not waste your money. You're adding extra security. That's always very good. And you're following the best practices. But you do not need that for now. You can add it later and create a new service. So yeah. Okay, while it's building, it might take some time, but I can actually drink some water, which I don't have much left of. Okay. So guys, okay, so yeah, this is the things you need to wait for sometimes, and in probably an hour or so we'll be working with SSL certifications, and I already pre-prepared that part, like the verification, because usually it takes not a lot of time. It takes like a few seconds, maybe a minute, but it can take up to 48 hours. And if I wouldn't, let's say we're not that lucky and something bad happens, we would need to wait probably for at least a few days so that I could continue the tutorial. So I prepared that. Actually, while it's loading, and it finished. I thought I'm gonna take some water, but yeah, now that it's done, everything is created, we see success, we can go back to our task definition creation. And now we can, maybe can refresh it and select our created VPC, Reminders API VPC. Now in here, what we need to do is we need to select for the subnets 2 well, we have only 4, but it's very important to select private subnets because and at least in 2 availability zones. And here you can see at the end those available, or here availability zones like US East 1B and US East 1A. This is gonna be good for security, and it's gonna be very high in availability because we have 2 zones. Okay, so now that we selected these, and if you chose the default one, just choose like default and leave all of the subnets that you have. You might see an error saying that you cannot, for example, here I have US East 1B, and here I have for private US East 1B. You cannot have it that way. You can have only 1 per availability zone. And because I don't need public here, these are in different availability zones, so it's good to leave it like that. Now for security groups. We will create a new security group because we will need to expose a few ports, and I will show you while explaining a little bit. But basically, this security group will act kind of like a firewall. Probably you know what that means. It controls what can talk to our tasks. Basically, it's a wall. It checks, okay, can you talk with our tasks? Yes, please go. No, go back. So that's what it's gonna do. And we'll need to create, for now, 2. First of all, we will create custom one on a port range of 3001, basically the same as we have our API listening to. We will select as anywhere the source, and it will allow to talk with our API basically from anywhere. But we'll also create another rule for our health checks later on that we will create. And for that, simply add HTTP. For now, it's HTTP, it's not secure, but later on we will add HTTPS and make it secure, everything very good. So now let's select anywhere as well, and we can continue going further. You see, yeah, this public IP, we will set it off, and what it does is basically this assigns a public facing IP to our tasks, which affects security and also billing, so we do not need that. Service Connect, we do not need. Service Discovery, we do not need that, and I have it in my guide why. But load balancing, we will need that. So let's enable load balancing. And now, what is load balancing? Load balancer is like basically a service that distributes incoming traffic across multiple servers or basically instances to basically ensure that no single server is overwhelmed, which improves our application's reliability and performance as well. So it's a very important thing. It basically what it does, it also has some sort of fault tolerance, because if one healthy instance fails, it reroutes everything to another. If one instance fails, it reroutes everything to a healthy instance. So this is very important, especially for big traffics and scalable applications. So let's select application load balancer. You will have this created selected container automatically, so just leave that. Or if you don't have it, select your container, and then you will need to create a new load balancer. If you have your own, you can choose existing, but if you're starting from scratch, more probably you will not have that. So what we will need to configure here? Well, first of all, we need to provide a load balancer name. So I will say reminders and API, and you can have LB, but I like to have it very clear. Reminders API load balancer. Now we'll create listeners for this load balancer. And for testing, we will leave port 80 with protocol HTTP. But later on, once we implement SSL certifications and everything, we will change it. So for now, we can keep it like this, but we will make it secure in a second. For the target group, we also need to create a new target group. So for you, probably you can leave the same name, or you can have, I don't know, something like ECS, Reminders API Service, or I will leave it default. So that's more than good enough. Then for the protocol, we will leave HTTP. For the registration delay, 300 is also good. and health check protocol will be HTTP. But now what's important here is you remember the path that we created in our application with /health. This is the thing I was talking about. Our load balancer will be sending a health check request to this. Basically, we need to specify to which path, which in our case is /health. And if we return 200, saying, okay, everything is working, then it will say, okay, this is working fine. We can send traffic to there, basically. So yes, I think that's good. Everything is selected here. We can scroll further. VPC lattice, we also don't need that, but service auto-scaling, we definitely need that. So now what is auto-scaling? Well, as it says, it automatically adjusts the number of running tasks that I talked about earlier based on the current traffic and load on those tasks. So basically, based on how different tasks utilize the CPU or memory, it will adjust, basically either add more tasks or reduce the number of tasks. This will help to maintain the application performance during the huge traffic spikes, but also optimize the costs when your API is not being called that much, when the traffic is low, let's say. So this makes it very performant while also handling costs for you. So definitely use that. Use service auto scaling. And now we will say, and give some settings. Well, first of all, is we need to ensure the minimum number of tasks running at all times. Like basically how low can auto scaling scale? And for I think maybe we set the task. Yeah, here we said like the desired tasks should be starting 2, and this is the tasks I was talking about. But in here we can, where is it here? We can say that if there is no traffic at all, if it's idle, you can scale down to 1 running task to save me money. Probably if you really want high availability, you can still keep it on 2. If your let's say API has a lot of traffic all the time, but yeah, for us 1 is gonna be good enough. You can change this later also, I think. Don't remember, but I think yes. For the maximum, we'll check it out. For the maximum number of tasks, we will select basically the same as we selected while creating the task definition. So the maximum number of tasks, actually no, there we created a different thing. But for the maximum number of tasks, we will say something like 3. When you're just starting out, 3 or 2 even is a good starting point. I think 3 would be ideal, because basically we're saying like if there's huge traffic, you can add 3 tasks, but if there's no traffic, you can add 2. And I think that's gonna be more than enough for most. Now for the scaling policy, we need to tell our service when it should scale up or scale down. So first of all, we will need to provide the scaling policy name. So we'll say again, reminders, API scaling policy. And for the metric, we can choose what are we tracking, either CPU utilization or memory utilization. For us, we'll track the CPU, and probably for you, you also need that. Now here we need to specify the value when it should scale up, or what target value it should basically reach. So when it reaches 60% of utilization of our task, I would say let's increase it to 1 more task. It's very common also to use 70. That's why you saw here default as 70. So it's based on you. Maybe you can even actually select 70 as well. And now there's 2 more values. One is called scale out cooldown and the other scale in. What scale out does, it increases the number of tasks when the traffic increases. So basically goes up. But what this basically exactly scale out cooldown, the very important word, this helps your app to handle more traffic, but it also specifies how long I should wait if there is still a lot of traffic before adding another task. So for example, I added 1 more task if for 300 seconds there's still a lot of traffic, over 70%, add another one. So I think the scale out could be a little bit less, something like 240, or maybe even less for you, because if there's a lot of traffic, we want to make sure it's performing well and adding enough number of tasks. And scale in cooldown, it's how long ECS will wait before scaling in, basically removing tasks again. So let's say you had 3 tasks. We saw that, okay, there's not enough traffic. We scale down to 2 tasks. And you do not scale down right away to 1 again. You wait for 300 seconds before you, if you see that, okay, there's still not a lot of traffic, you scale down once again. So you can choose this however you want, but this is a good starting point, very good starting point. Okay, so now we will skip the rest as everything is defined here. I think I didn't skip anything. So now that we went over all of this, we can click create and wait 1 more second. So now that we have, actually it's not done. I see it's still in progress. It created the service, but now what it's doing, it's running these tasks. And these tasks are actually our application. So if you go here on one of the tasks and click on logs, you can see like the logs that we are doing inside our application. Here, example, listening on port, and this port they're taking from the environment variables that we've set up. So that means it's working, and if I go back to tasks, I can see that it's running. And this one, it's because we wanted to start initially with 2 tasks. It's activating, but later, because probably will not have enough traffic, it will scale down to only 1 task, and you'll see how the auto scaling works. But now if we go to services, if you selected your default VPC when creating this service, I will show you once again where is it. So here in networking, if you selected this default, you will not need to do this next step that I'm showing. But if you created your own, you will need to do this step. And here we have 2 tasks running, everything is completed, and everything is working. So if you, as I said, chose a default VPC, you can go to your services, configuration and networking, open the address here, and this is actually your link to your API, and I see you don't see it here, your link to your API. But for us, because we used a custom VPC, we need to do some adjustments. And what we need to do is go here to load balancers, and don't forget, go to EC2 feature, not light sail. So if we go here, and if we select our only load balancer, if you have more, that's why naming is important, click on this one. And in here, we need to go into network mapping. Yes, network mapping. And under here, click edit subnets. You can right away see here, because when we created there and attach those subnets, it attaches these subnets, the private ones that we selected, also to the load balancer. But our load balancer needs to be facing, basically using public subnet. So that's why when we go here, we will choose the public one, and you can here see it says public. So let's choose this public, here also public. Let's save changes. It will take you it might take you more time, 5 minutes or 10 minutes for these changes to get into effect. So I'm not gonna right away test, I will wait a little bit, but we can go back to our ECS, Elastic Container Service, to our cluster and to the tasks. Well, let's try to see if it already took effect. If you go here, go to configuration and networking, click on open the address. So yeah, for me, it's still didn't take basically effect. So I will need to wait a bit longer. We can close this, the containers, we will need that in a second. So let's wait a bit longer. Maybe take a sip of water. There's a lot of waiting. So what time is it? 1:53. Let me check. Okay, so let's see what next we will do. Here are some skipped. Yes, yeah, some more explanations. Good. Let's go to the new board. And actually, before going next, I will want to showcase you, and I have somewhere in my notes what I want to showcase you, not to forget. Let me open the notes and see. Yes. Yeah. Found it. So a few important, actually, let's check real quick before, and it still didn't take effect. So let's wait a bit more. A few things that I wanted to show. One quite important thing is health and metrics. In here, if your reminders API load balancer doesn't have healthy checks, if it has some unhealthy checks, that means something is not working. That means you can try to go to logs and see what the error is. You can see some of the errors here, or maybe you can even go to here health basically section and see the CPU utilization or memory utilization. Later on we will see some spikes here. So that's actually one of the ways how you can see that maybe we need to increase the CPU utilization or memory utilization, I mean the capacity. So to do that you would go to like task definitions, and I wanted to showcase you this a bit later, but you could create and attach to your tasks more memory, and here it says incompatible with memory 3, so you would give something like 5 and maybe 2 vCPU, and then also you could change the limits if you wanted to. For us, we don't need that, so we will say cancel, but this is how vertical scaling works. If you see that some tasks are failing because they are out of memory, or your CPU memory that I just showed you inside the cluster, reminder cluster, task, service, and health, if your CPU is all under constant high load, probably you need to increase either memory or CPU. And in here you see that it's only like 1.5%, and here is 0.5, so it's good for me. I don't need to increase that. And then, for example, there is also horizontal scaling when we can add let's say go here and update the service, and we can add more tasks. So if you go to auto scaling, you can add, let's say that maximum number of tasks, you could have 5. And that's how you horizontally scale your API. And this is usually, you would do that as a second thing, because you can see like if you are having a high request volume and you want to handle more concurrent requests, then you would increase this. But at first, you would increase the CPU and memory inside the task definition as I showed you. And in a second, I will show you how to use this new task definition, because currently our service, if we go here, is using the task definition of version 1. So we will see everything in a second. So now if I go to configuration settings and I open, yes, now it's finally working. If I go to reminders, we can see that our database here returns us all of the reminders, the same ones with buy milk, ID 35, all of the ones from our actual database. That's amazing. That means it's working, everything is set up, and we can continue. But we right away see one huge issue. This URL, even though you could use it, is first of all not secure because it uses HTTP. And second of all, it looks very ugly. I would not imagine you remembering this URL. So we will try to solve this. And let me actually check if everything is good. Yeah, I think it's good, the sound, because yeah, it's going to be important. So now what we will do is we will go to, I just showed you, actually right now I can show you how to do a new update. That's going to be a good. So for example, if you change some code in your application, and to see the changes, maybe let's add something like console log and say new version. Yeah, let's save it. So now let's say you've created a new version, some changes. How do I release this and update it in my ECS? Well, it's actually quite straightforward. First of all, if you have my guide, it's always going to be up. You can simply go to pushing images to ECR lesson and go over all the settings. You might need to log in, just copy it and read everything here. So this is the function to build it. You can also, as I say, automate this whole thing. When you push to Git, it automatically pushes your image to ECR. And maybe if that's something you're interested, I might show in some of the live streams. But for now, if we go here, we will build once again another image, but now the version, because it was a small change, let's say it's gonna be 0.1. Let's click enter. It builds this new image. Now what we need to do next is tag this image. So we go here, we copy this. Don't forget to also change here the tag number, and we also need to change it because now in here, let's say if I restart, this is with the tag of 1.0.1. So we need to say that use this image tag. So let's do that. And if we go back here, we see that we have a new one. So now the last thing that we need to do is simply push it to our ECR. So we would say docker push, and we also say that this with a tag of 0.1. We wait a second for it to be pushed. Let's go back to our container registry, reload it, and we see that we have a second image. And this image is with a different version, which means we're trying to release this new version. But how to do that? Well, let's go to our task definitions, select our task definition, and this is actually the best practice way. There is an easier way where you, as I say, keep the tags not as 0.1, but keep it as latest, and then you could just go to clusters, reminder cluster, and select this cluster, and you would force new deployment. This is not the best practice because if you tag these with latest, you might have issues with rolling back. So for example, if you're trying to release a new version, this version is bad, something is not working with this version, you would not know exactly how to roll back to the previous one nicely. Sometimes there can be some misconfiguration. Also, it's hard for yourself to track which image are you running right now, because you can always check here inside the services, selecting the server inside the container. You can check which version are you running. If you had latest here, you would have no way of knowing if it actually released or no. So the best practice would be to also keep always that versioning. So let's go to task definitions, select this task, and let's create a new revision of our task definition. And here, where you could create, as well as I said, increase the memory if you're seeing that it's not enough, or some CPU power. But for us, what we will need to do is we will simply need to change the image that we're using. So instead of using the 1.0.0 version, we will use 1.0.1. So this is essentially the only change we need to do. So let's go scroll to the bottom, click create. Now, if you go to task definitions and select the task definition, you will see the task definition with a version of 2. Now you need to go to your clusters, reminders API cluster, and in here we need to say update the cluster. Oh, not the cluster, sorry. We need to select, go back to reminders. I mean, we need to update the cluster, not the service. Service. I'm already, messy. The names are in my head. So you need to update the service, not the cluster itself. So because the service is running that image. So you go here, select your service name, click update service, go to the task definition that you're using, but now choose a different version. Choose a version of 2 and simply scroll down, click update. And now if we go to reminders API service back here, we will actually services here. Yes. If we reload this, we will see that the deployment is right now in progress. So we need to wait a little bit until it's completed. And once it's completed, we should see our newly built image with the console log of new version out. So once again, right now we will not have to wait that long because previously it was also creating the service, but we will need to wait a little bit. So here it's trying to run these tasks. Once again, we can take some water. Hello from Somalia. Hello, hello, hello from Lithuania. Patricio, are health checks done via Node.js route? Yes, exactly. This is the route. Basically, we selected the name health. You can have whatever you want, health check here, but then when creating a task definition, make sure to select also that the path is health check. And that's how the health checks are made. So now, okay, now that we see that our tasks are running, and if you go to the service, if we reload this, actually it still says it's in progress. So we'll wait a little bit more because what it's doing now, let's see, let's reload. It's stopping the old tasks and now running the new ones. So now it's deactivating, probably it's still not done, but actually we can check our new tasks right away. So if we go to logs, we can see that we have a new version, because we ran two tasks, basically two APIs. We are seeing it 2 times, but it worked. That means we released a new version. You can actually go to tasks and select a single task and go to its logs and you'll see only one new version. So basically you're selecting single application and we're seeing that it's calling new version and then listening on port. So that's how you would do updates in the future. That's how you would release them. Or via CI/CD, but this is, we're not going to cover in today, maybe in the future. So now, okay, I showed you how to release new versions. Now it's time to make our finally let's go here. No, here. Our links look nice. So how to do that? Well, first things first, what we need to do is we need to go to Route 53. And actually, if you go to the Notion guide, you can click on this last lesson. And here I have everything that you need to do, like step by step. I will guide you inside a video, so you can watch the video, but here I also leave some small notes. So yeah, you can read it out. The first thing that we need to do is we need to register a new custom domain. So to do that, go to registered domains here. And inside here, just click register domains. Here, find whatever you want. So something like notjust.com and .com is not available. So it will suggest you some other, something like, yeah, not should. Find whatever fits you, click on select and click on proceed to checkout. In here you will need to complete some forms like provide your contact info, enable auto renew, enable privacy protection, and then you will need to complete the purchase by providing your credit card details. Then AWS will send you a verification email, just verify it, and this purchase should be done. You can buy the domain in a different registrar. It's just easier if you buy it in AWS because you are already inside their infrastructure. But you can more or less follow the steps exactly like I will show you, but you would need to change the server names. So I would still suggest buying here. It's only like maybe not only, but it's in a way you think it's only $14 per year. So if you divide it, it's not that crazy. But yeah, you can buy it cheaper for sure in a different registrar. But now that after you purchase your domain, we will leave it because we already purchased it. It might take a bit longer. I didn't want it to waste your time. So when you purchase it, if you did it in Route 53, you can go to hosted zones and you will see this is what I purchased. Here we have some other ones, but this is the one that I want to use as my domain. So now we need to request an SSL certificate for our domain. To do that, what we will do, we can already close this Elastic Container Registry and go to Certificates Manager, open it in a new screen or in this one. And I already created this certificate and I already approved it. I will show you how to do it still. I did it because in theory, usually it takes not a lot, like maybe a minute, sometimes 5 minutes to approve it. But sometimes it can take up to 48 hours. That would be way too much to wait again. So I didn't want it to risk it. So I thought I will do it right now, but I will still show you how to do everything. So what you would do is you would click request and select request public certificate. Next, in here you can provide your domain name. So you could say simply, because I purchased notjust.dev, and you can go here actually and check what you purchased. So you can just copy this. You can have it for only for the basically root domain, the certificate, or you can have for everything. So for example, in the future, if you would like to have API notjust.dev or production notjust, so basically everything that you add here, you also want to have certified, you can use a wildcard. So this basically says everything that goes in front, and then this, we are trying to get the SSL certificate. So you would have here my domain dot something with a wildcard. So now in order to showcase you how it's actually done, I will use something like API prod. But you still use the wildcard. So now for the validation method, choose DNS validation. That's recommended and for good reason. And for the key algorithm, use also the most widely used one. Click request. And now we will have in a second our CNAME loaded. So let's wait a second. Maybe we can, yeah, now perfect. So now you will see something like this. Your domain name will be different with the asterisk here, basically a wildcard. What we need to do is we need to copy the CNAME, go back to our hosted zones, select our hosted zone, and click create record. In here, what we will do is we will CNAME, like basically paste it as here, but as you can see, it already adds the end here. So what we need to do is simply remove this last part. Okay, now that we have this pasted, what we need to do is go back to certificates and copy the CNAME value. So let's copy that, go back to our hosted zone, select in record type CNAME, and paste the value. The value, you should paste all of it. Then click create record, and it will create a new record here. As I said, it might take 60 seconds or it might take up to 48 hours. So I didn't want to risk it. That's why I created, but let's see. Maybe it would have went well. Actually, yeah, it's already, you see the status changed to issued. That means it would have worked right away. But this is how you get that certificate. So, but I will use this one with a wildcard. I just wanted to show you everything step by step. You should have something like this with the asterisk. So now that we have this certificate, we need to enable HTTPS in our load balancers. So what we will do is in here, we will say go to load balancers in EC2 feature, open it in a new screen. And let me check if the sound is good. Yes, you go here. Then you select your load balancer. And under here, we will select add, under listeners and rules, we will select add new listener. In here, we will say the protocol now, it's going to be HTTPS on a port 443 Then we will have forward to target groups, and and we will need to select the target group, which is what we already created. If you remember, for reminders API service, that's good. And is there any important settings that I'm missing? Yeah. Yes, very actually important setting that I'm missing. If you scroll here in secure listener settings, under default SSL and TLS server certificate, select your certificate with an wildcard asterisk. Select it, and basically now that's it. What we need to do, scroll to the bottom, click add. It added a new service. For now, it's not reachable, and it's okay. I will show you why it's not reachable. But what we need to do is we need to edit our HTTP 80. And what we will do with it, just click on it, select it, say actions, edit rule. And what we want to do here is we want to redirect, when someone is going to, let's say, HTTP and our URL, we want to redirect them to HTTPS. Not just show that there is no website or API like that, redirect the traffic. So what we will do here is we're gonna leave the HTTP 80, but now in default actions, we choose to redirect to URL. In here, we will choose URI part, and what we are choosing here is HTTPS on a port number of 443, the thing that we had in there. So just do this and click Save Changes. So now if we go back to our load balancers, we still see that this is not reachable. And it is not reachable because our security group, our firewall, is not, it won't let it go past. So what we need to do is go to security groups as an EC2 feature, open once again in a new screen. And once we're here, we can go to the security group that we just created. If you have multiple, most likely you will have a description of created in ECS console. So just select it, and we right away have some rules predefined that we selected, but we need to add a new rule. And to add a new rule, click add. And now we need to allow HTTPS, basically also from anywhere IPv6. And also let's add a rule for IPv6. Now we added for IPv6 and for IPv4. Where is it? HTTP. And then for IPv6. Yes. So the other way around. Now that we added these, we can click Save Rules, and now we'll have more inbound rules. But if we go to our load balancer, and even without refreshing, we can see that it no longer has that issue. So now, if I go to my ECS, let's go through here, Elastic Container Service, go inside the service, configuration and networking, and open this address. Because yes, right now it's because the link is not very good, is it's saying that this connection is not private. But basically we already see that it has HTTPS here, and if we, let's say, remove and make it HTTP, if we go back, we see that it redirects to HTTPS correctly. But now the last step that we want to do is we want to use a custom domain for it. So in order to do that, what we need to do is go to our Route 53, once again, in here, go to hosted zones, select the hosted zone that we purchased or created, press create a new record, and now let's give a subdomain to our, what link URL we want to have. And I will say something like reminders, API. Maybe you can even have something like prod reminders API, and then different for development, notjust.dev. The record type will be a, we will turn on the alias, yes, choose the endpoint, and we will choose the endpoint to our load balancer. So write load and select alias to application and classic load balancer. Choose the region. The region is going to be the same as if you go here to your load, to your ECS, or even to your load balancers, you can see your region here at the top. So in my case, it's US East 1, and also probably use the same in your CLI. So if you go back to route, no, where is that? Yeah, nope. Yeah, here. If you go back here, we select the US East 1, North Virginia, and then you should see already suggested load balancer for us, and we can see that it's reminders API load balancer. So you can select that, click create records, and yeah, usually again, it right away should work, but it could be that it takes a little bit longer to propagate. But let's try. Let's copy this one. Let's open a new tab and let's call /reminders. If we go here, actually it works right away for us. We see that connection is secure with a lock here. We see that it's HTTPS, and if we go to HTTP, it's just getting redirected to HTTPS, which means everything is working. So now you can take this URL, go to and use it in your application. So even if I open, let's say, Insomnia, something that I've showed 2 weeks ago how to use, if we go here, let's say for get all reminders, and I paste from this ugly URL to nice, actually I already added this, to a nice URL. If I click send, I can see right away that it's in production, secure, and I get all of the reminders. I can even create a new reminder. So for example, let's see, the latest reminder is buy milk. So if I say create new reminder and I use this URL, in the body I provide creating new reminder with a asterisk, and the user is gonna be, let's say, with ID 3. If I click send, I can right away see that the reminder was created, but to definitely check it out, let's go to get all reminders, call this API, and also we see creating new reminders. So that means everything is working. Our API is securely hosted, and that's it. These are all of these steps I wanted to showcase you today. I think, let me double check my notes if I'm not forgetting something. But yes, I think I'm not forgetting anything. Yeah, so that's it. If you have any questions, you can ask them now. I will try to reply them. And I see James is asking, is this taught also in React Native Mastery course? It is not taught in the Mastery course. But yeah, you get it for free. That's even better. So use it, ask me questions, go download the Notion guide. You will have even more information there. And always I've tried to update it. If there's any questions on YouTube that I see are repeating a lot, I'm trying to update it here. So yes, that's that. We have everything done, and I don't see any more questions. So I think we'll be able to, I feel that it finished way too fast. Usually my streams at night, and this one was a little bit shorter, although very important, especially to see how you take it from local development to actually publishing and using it. So yeah, if you have any questions, ask me. I will wait a few more minutes, but I think we will be done with everything. Let me check if I actually showed you everything that I want. So this is, yeah, I feel like I did. So yeah, and actually, so now if let me show real quick. So now if I reload, as you can see, we're running only one task, and maybe you don't see it that well because of my head, but here it says one task out of one running. And this is because of our auto scaling. It saw that there's no traffic. We can scale down because it's gonna be enough, and it has running only one task and the other one is stopped. But if by some reason we start getting a lot more traffic, it will add one more. And if the traffic is still huge, it will add a third one. So yeah, that's how it works. That's why it's so good. And here we can see the CPU utilization and memory. So I think I've showed you everything that I wanted. I hope you liked it. I hope this will help to some of you. And keep coding, guys. I'll meet you very soon. I hope the ones that are participating in the hackathon are having an amazing time. You're finding enough time to build it, and I hope to see your application already there. I will test them all, so I really can't wait for that. But once again, thank you very much. Have a nice evening, day,